how fantastic to see everyone here today. I've spent the last 2 decades of my life dedicated to finding solutions to eradicate textile waste, to replace the use of virgin materials in textiles. And I think today is testament to the fact that we are on the right track now. So that's very exciting. I started out 2 decades ago with a company called Worn Again, which subsequently became Worn Again Technologies in 2012. And the sole purpose and focus was to find solutions to eradicating textile waste. So since 2012, we've been in development of a chemical recycling process that can take in pure polyester and polycotton blends to recapture those raw materials, to go back into textiles all over again. And one of the questions that kept coming back during the development of the technology was, okay, imagine, fast forward into the future, we have a large-scale recycling plant up and running. Where are we going to get our feedstock from? And that led to my next business, which is an early stage startup called Circulate Textile Ecosystems. And it's all about this. So if we look at, and I apologize for everyone in the ACT project, we've seen these slides 100 times, but I think there's no harm in reiterating. We've heard a lot about the problem, raw material production coming from virgin sources, going through the supply chain, being used, being collected or not collected. You can see the flows going into landfill. And then of the materials that are getting collected, some of them are being sorted manually here in the UK for reuse. Some of it's being exported for sorting. A lot of our NRT are being exported, which is the very material we want to be able to get back into fiber-to-fiber recycling. And so I guess the big question is, why are we exporting it today? Well, the economics actually support the export of it to other countries. And I think, when we talk about this idea of circular economics, how do we flip those economics so that we can do the sorting and the recycling here more regionally? And this brings us to a very futuristic diagram that doesn't quite exist yet, but it's what we're working towards to move to a fiber-to-fiber future. And you can see on the left-hand side there is the wonderful chemical recycling, all industrialized. We've got Worn Again here, but of course there are a handful of other both mechanical and chemical recyclers in development and at various stages of industrialization. And really that's the real shift that will change everything. But once those recyclers are up and running, we're all going to demand very high volumes of consistent feedstock supply, which is why the kind of precursor to mechanical and chemical recycling is what we call an automated textile sorting and pre-processing facility, which is an enabler to moving from manual sorting of non-rewearable textiles to an automated system that can turn end-of-use textiles into feedstock for recycling. And that really is the clincher for turning those economics that don't work today into what will work in the future. And that ATSP is really at the heart of what we have been developing in the ACT project. It was about 1.5 years ago, I think, maybe a bit further, where Circulate got together with UKFT. And many people in this room have been working on moving government opinion and shifting and talking about the need for moving to automated sorting as a stepping stone for chemical recycling. And in their favor, the ACT project, well, before it was ACT, it was a government grant that went out, that we all got together, put together an application, and received $4 million in funding. And it's been a fantastic process. We're, a year and a half in now? Something like that. And the focus of our work stream here has been the design and the development of this automated sorting facility. This is a 25,000 ton per year plant that is able to take in non-rewearable textiles, chop them up, well, first of all, separate by fiber composition, then chop them up, remove all the buttons and zips, as Elizabeth was talking about. And then there's a size reduction step that can chop it up into the pieces and the fiber specifications required by each of the different chemical and mechanical recyclers that are out there. And really, without this is what will bring this scale. This is what will bring the economics that will enable fiber-to-fiber recycling. And as part, Louisa's standing behind me. As part of the project, we needed to bring in an engineering design company to help us design this facility and the process, what happens inside of it. And we, about 6 months ago, partnered with TOMRA to bring them into the process. Given their global expertise, they've been, Louisa will talk for herself, but they have been focused on sorting all sorts of materials for decades across many different industries, from metals to paper to blueberries and oranges. And they've more recently been focused on textiles, which is why we've brought them into this project. And on that note, I'll hand it over to Louisa.
Thank you, Cindy. I was told not to touch the mic earlier, so hopefully you can all hear me okay. Just to introduce TOMRA very quickly, as Cindy said, we saw all sorts of different types of technology. We are 52 years old this year, and Ross, to your point on the theme of revolution, we call ourselves in TOMRA resource revolutionaries. So everything we do in TOMRA is centered around the circular economy and making sure that the resources on our planet last as long as they can. And we do that by developing optical sensor-based sorting technology that can detect and sort different materials to prolong their life, to recover them from waste, to make sure that they are fed back into circular systems. So everything we do at TOMRA is around making sure our resources, whether that be metal or plastic or now textiles, goes back into a closed loop. So we've been doing that for the last 50 years, and now within the last 5 years we've been taking that technology that we've been developing and applying it to the textile value chain. It says here that the broken value chain requires active engagement. I would say the value chain today isn't necessarily broken, it functions very well in its linear capacity, but what we want to do is now use our optical sorting technology to shift that linear value chain into a circular value chain. And optical sorting technology is a core component of making that shift. We need to scale optical automized sorting technology at high volume to enable us to take in the waste textiles that we're producing and feed them back into a closed loop fiber-to-fiber system. So at TOMRA Textiles, we set up TOMRA Textiles as a separate corporate venture last year, so operating slightly differently to we do in TOMRA, but allowing us much more flexibility and allowing us to develop our technology that we have at the moment specific to textiles. Textiles is a lot more complex than some of the materials that we've already been sorting for many years. It's a lot more complex than plastic or paper sorting. So within TOMRA Textiles, we're now dedicated to developing our technology for being able to detect and sort textile waste, to build, own, operate and scale sorting facilities across the world, to stimulate ongoing regulatory development. So we've got a fantastic public affairs team that work closely with local governments to incentivize and create that legislation that we need. And also co-create and partner. So exactly, that's why we're here. We've partnered with Circulate in the UK to see if we can scale the UK's first ATSP. And exactly where do we sit in this value chain? So along the top, you can see the traditional linear value chain. And then in the bottom, this is the value chain that we need to create, that we're all here today to hope we can scale. And exactly where do TOMRA fit in? We have the optical sorting technology, which is critical to close the gap between the waste textiles we collect and the fibre-to-fibre recycling technologies that need that fibre. And also pre-processing. So as Cindy mentioned, we're not just looking at sorting, but also pre-processing the sorted waste to prepare it to be a raw material product to go directly into fibre-to-fibre recycling. But that's not all we need to do, and we can't do that alone. So a sorting facility is not a standalone facility. In order for us to enable these solutions to scale circularity for textiles, we need new collection systems. So we need to collaborate with waste collectors, sorters. Pre-sorting is a critical component as well. It's not a TOMRA core competency. So there we look to the industry, the existing very well ingrained, defined traditional collecting sorting to see how we can divert and create new non-reusable textile flows. Of course, sorting for recycling with sensor-based sorting technology. Pre-processing, as I've mentioned and was mentioned previously by MTR. How do we chop and cut down the materials? How do we remove the metals, buttons, zippers? And then again, how do we feed that into recycling and downcycling applications where we need? So we sit, I think, in the middle of this spider web between the waste textile collected and the fibre-to-fibre recycling, but we don't stand alone. So there's an incredible amount of collaboration that's needed in this. Ongoing initiatives for TOMRA Textiles, so technical and commercial co-creation. So we're developing our solution, and we're also looking at other technology and machinery suppliers that we can develop and scale this with. So we're the engineering partner for this ATSP, and we're looking at the best engineering concept for that. What are all the different types of technologies for cutting, shredding, feeding materials onto the belt, sensing and detecting the materials? What does that best concept look like? Collaboration agreements. We've signed a collaboration agreement, for example, with Carbios, and we look to do that with more recyclers. How can we enable recyclers to scale their facilities? We need to be able to prove to them that we can supply them with the material that they need, at the purity that they need, at the specification that they need. And we're also setting up a dedicated textiles test center in Germany, where we will test the whole concept and gain operational experience. Like I mentioned, textiles is a lot more complex than the materials that we've been looking at over the last 50 years. So how can we set up that full flow of materials coming in, being spread or fed onto the belt, being evenly distributed along the belt, being sensed and detected, being sorted, being chopped, being cut, metals, trims, removals, all of those. How can we do that? How can we gain that operational experience and enable this first ATSP to be developed? So we're doing these in conjunction. Exactly how does textile sorting work with NIR? I had a small panic this morning, but I'm going to remain calm. I had a small panic because we have a diagram here that comes from our plastic sorting sector. So I'm just going to ask if you could imagine those bottles as items of clothing. But the material will be fed onto a conveyor belt. There's different types of technology and machinery at the beginning of the process flow there that will be able to distribute the items onto the belt. They need to be evenly distributed. They will then pass underneath the NIR and visible light spectroscopy sensor. So NIR is used to detect the fiber composition. Is it polyester? Is it cotton? Is it a polycotton blend? What is it? The NIR sensor will be able to detect it based on a reflection of the material through the wavelengths. On top of that, we will have visible light spectroscopy, which can look at the color of the different materials. So we can sort by both fiber composition and color. And then using compressed air jets, a signal will be sent from the orange box, which is the TOMRA detection. When an item has been identified that we want to separate, a signal will then be sent to the compressed air jets, which will push or force that item of clothing over the barrier, and there having a separation of the material that you do want and the material that you don't want. And similarly, we're looking at both sorting and pre-processing, and what are those critical components of machinery and technology that we can combine with our sorting technology afterwards to cut the material, to sense the metals, to remove the buttons, remove the zippers. I think this is one of the main reasons why clothing and textiles is so complex compared to paper or plastics, is because of all of those different complexities, all of the different fibers that are used, the blends of fibers, the additional pieces that we have on our textiles. It makes it quite complex, but these are what we're focusing on. And finally, we released a white paper at the beginning of this year, and we set out our 4 key beliefs of what we believe needs to happen to make this transition to circular textiles. So supportive policy and legislation, collaboration, innovation, and the final one is a robust digital core. So making sure that moving away from the value chain that we've had at the moment, where perhaps at the end of the life of the garment, we don't have any traceability or tracking of that material. So how do we build up this new infrastructure with a robust digital core so that we can provide information back to the value chain to say, for example, brands, we've received this volume of material, we processed this material, X amount of your fibers have gone to be recycled back into new fibers. How can we create this new system that's transparent and has traceability within it? There we go.
Thank you for the presentations, both of you. Now we have a set of questions about the key areas of the ATSP, where we would love to get your insights based on the work that you have been doing. So, first one, Cindy, how important has the ACT project been to convene and create the ecosystem needed in the UK?
Very important. And thank you, Louisa. You mentioned the digital element, which I forgot to mention, is absolutely key to bringing the whole transparency and accountability that the industry wants and needs to be able to report back its CO2 savings, its net zero targets that Joe was mentioning earlier. That is why we're doing all of this. But in terms of the ACT project and the importance of it, it's really cracked 2 nuts, I think. First and foremost is we always, for years we've been talking about the chicken and the egg. When do we bring automated sorting in? You know, chemical recycling doesn't exist yet really at scale. So why would anyone start evolving their infrastructure or invest in technology to sort for chemical recycling if it's not here? But the thing we need to prepare for is the second that switch goes on and those chemical recycling plants are up and running, there's a huge flow of materials, as you saw on the slide earlier, that are leaving the country. We need a couple years to get this infrastructure set up. We need to invest in those new flows of materials and work out how we're going to get those NRT, the non-rewearable, separated from the RT so that they can go into recycling and your rewearables are reworn. So it's a question we've battled with for years, but I think the government grant that has helped bring all of us together has really helped overcome that hurdle. Without it, it wouldn't have happened. I really believe that. And then secondly, the other thing that I think has not surprised us, but has been just a really nice outcome is we all talk about collaboration, and it's one of those overused words, but the fact that all of the collector sort, not all, many of the collector sorters, some of the brand retailers, the industry associations have been involved in really working together on these different work streams around new collection systems, around designing for recycling and all of this stuff. And it's helped build some of the core relationships. We need more to actually start delivering this stuff on the ground. And I think that's the key shift. It moved things from talking about it to actually doing. So I think we should be happy
really
for that.
Really important that.
Yeah.
Thank you, Cindy. Luisa, do you have anything to add on that one?
No, I agree. I think alongside the 4 key beliefs that we have, it fits perfectly into those investments, funding, and collaboration, like Cindy said. We're at such an early point in the shift towards circularity and shifting this whole industry into circularity. That funding, I think, is critical in these early points. We wouldn't necessarily look in the long term to scale a sorting plant based on funding, but while it's so new, it really needs it, and that funding is really critical to get it off the ground. And again, collaboration is very much an overused word, I agree, but it's also critical. There are so many different parts of this value chain, and it needs a central point like the ACT project to bring everybody in, to coordinate it, to fund it, to get this new industry off the ground.
Thank you. Right, next question for you, Luisa. What are some of the key challenges that you have found when it comes to implementing a commercially viable solution?
3 things. Cindy's mentioned one already. Timing. The chicken and the egg. Is now really the right time? Is now the right time to do this? Is one of the challenges that we've faced. It's a significant risk. There's a lot of money involved in scaling such a big plant. So we need to know that now is the right time. And like I mentioned, there are so many different moving pieces to this shift, from the existing infrastructure, from the existing collector sorters, from the new technologies for recycling, from building a new plant. Is now really the right time. If we scale a 25,000 ton per year sorting facility and have output products of cotton, polyester, wool, etc., do we have the recycling technologies scaled at the end of that to take those and recycle them? Do we have the brands really committed to commit to taking that into their products? So timing is one of the challenges. I think economics as well, how to make this economically viable, potentially competing with price points that we might get for exporting this material. So how do we use business model innovation to create these new economics while there are already existing economics for some of this material? So that's been one of the challenges. Anything to add?
Well, definitely EPR not being here. It's a hard sell getting this off the ground now. But I think one of the things we're trying to encourage with this collaboration is the fact that, there are many existing collector sorters in the room. They've been working in this space for decades and decades. And this is a very new kind of concept that's going to affect everyone's businesses. And so what we want to encourage is the collaboration between all of us to make this first ATSP a success, to make it economically viable, to work together to show we can make the economics work, because this is what we need to get to fiber, to get the cost, the prices right for brand retailers to be able to buy recycled content. Chemical recyclers need to buy in at a certain price. And the processing that we do at the NRT level needs to be low cost so that they can afford the feedstock into their processes. So it's a complex new business model that I think ultimately, everyone's going to win from, because it's going to transition us to a fiber-to-fiber world. And if it doesn't work for everyone, well, then what's the point? So I think let's, carry on collaborating, working together, and making those economics work so that we can end up where we want to be.
Thank you.
Can I add one more?
Yeah, sure.
It was mentioned earlier as well, but data, I think, has been a real challenge. For us to set up a sorting facility, we need to know what's coming into the plant and what's going out of the plant. And to know what's coming into the plant, what exactly is the fibre composition, how many tonnes is it? A lot of this data doesn't necessarily exist. If I think to our plastic sorting department in Tomra, plastic is very well regulated. We've had collection systems for it. We know in a waste stream what the composition of that plastic will be. This percentage will be PET, this percentage will be PP. We have that data, but because textiles in this capacity, looking at recycling and circularity is quite new, there's such a lack of data there. So that's been a challenge. And again as well, the data in terms of a lot of these technologies being new and scaling now, feedstock specification requirements are changing. So I think, data is another challenge. But again, through creating these kinds of consortiums where you can all share information and talk and discuss, again, is critical. You can't scale this alone, so it needs these kind of forums where people can come together.
Really good point. And linked to the input and the feedstock, Circulate plan through ACT is to select the physical site by spring 2025 and perform the commissioning of the plant in 2026. So what are your current plans to ensure consistent flow of feedstock?
Flows of feedstock, good question. So I think outside of the project here, or in parallel with the project, our role at Circulate, beyond the ACT collaboration, is to raise the finance and beyond what was in the grant, which is much, much greater than what we had in the grant, to commission the facility. So we are raising investment, we are bringing in strategic partners in parallel to actually commercialize what we've been talking about. In terms of bringing in supply, I mean, absolutely, we've heard today, there are players already in place collecting very high volumes of materials, so we have to tap into that, absolutely. We also have to look at new collection but new collection routes. We need to optimize some of the costs of collection and handling, looking at logistics and that sort of thing. So I think, everyone has a role to play in this, even citizens, and looking at new ways of how we drop off our end-of-use textiles. Being able to separate into re-wearable and non-re-wearable is a really good way to kind of optimize the economics. So they step aside from one of the, having to go into a facility and people kind of looking at materials, putting one in one pile and one in the other. Any kind of way we can look at optimizing the economics is needed. And finally, I think that the volumes are there. That's not an issue. We have got so much end-of-use textiles in the UK. And it's not just post-consumer, it's post-commercial textiles. So there is, volume is not the issue, but definitely in terms of collection and optimizing that, we all need to work together on making that side of things a little bit more efficient.
Right, thank you, Cindy. I don't know, Lisa, if you have anything to add in terms of how do you think that the industry can join forces to overcome the current scalability issues for this type of facility?
How can, I think, collaborate, join, be a part of initiatives in the early stages? I think that's one of the best things. I think this is inevitable. We will shift, and we are shifting to circularity. We have passed the tipping point. It will come. It will eventually come with regulation, but whilst we wait for that, I think what the industry can do is be part of those early pilots, which will both help us get there faster and also help those that join the early pilots be prepared sooner and take hold of first mover advantage. So I think there are plenty of pilots and opportunities to join consortiums such as the ACT project. So I think that's one of the best ways that the industry can prepare for that.
Thank you. And Cindy, one message that you reiterate is that to achieve textile circularity, manual and automated sorters need to integrate and work in complementary manner. So how do you see manual pre-sorting and automatic sorting coexisting in the coming years?
Well, I think I touched on it a little bit earlier. There's all sorts of talk about being able to sort rewearables and non-rewearables using AI, maybe one day. But I think for the short term, definitely we're always going to need people to make those choices in sorting. So manual sorting is not going to disappear. But when it comes to the non-rewearables, I mean, you can't often tell by eye what a fiber composition of a garment is. So we need to move to that NRT and fiber-to-fiber automated system. Again, what is going to shift this is the scale. So if we can get this first facility up and running and we can prove the economics of that, then it's about replication. And again, everyone needs to be all hands on deck to make this first facility work, because after that, we do have enough end-of-use non-rewearable textiles to supply somewhere in the region of 15 to 17 ATSPs operating at 50,000 tons each. Like, there's enough to go around. So let's make the first one work. And then, you know, the idea with this design that we're working on for ACT is that it's a blueprint. It will be a design that can be replicated and bolted onto existing collector sorter facilities. So it's not an either or, it's an integration into what's currently happening today. It's not replacing, it's just optimizing. Yeah.
Thank you, Cindy. And linked to the design of the first ATSP in the UK and the design, Luisa, what is the approach that TOMRA is using to design this type of facility?
Very basically, when we design a sorting facility, we need to know what's coming in and what should go out. So what's our feedstock composition coming in, and where are the sources of that material coming in from, and where should the outputs go? And then comes the complexities of, okay, we will source, and we want to source the majority of the feedstock to be from post-consumer. Okay, then what's the fiber composition of a ton of post-consumer material? Then we go into the details of understanding what exactly is coming into the plant. Once we know what's coming in, then we can match that to what will go out. What are those recycling technologies on the output? What are their feedstock specification requirements? And then then the input and output go into what does that plant look like? What flow of material, or how does that material need to then flow through the ATSP? Which would be, through optical sorting technology to recover, for example, cotton, polyester, polycotton, all of those materials that have a designated end use, and then working backwards from the recyclers to understand, do you need the material cut or shredded? What are your feedstock specification requirements? What are your critical contaminants to make sure that we can find the right combination of different technology, both optical sorting technology and cutters, shredders, fiber openers, to what degree we need to then combine all of this different technology and set up an ATSP. I think at the moment, whilst we're in such an early stage of designing these kinds of facilities, each facility will be case specific, based on where we will source the feedstock from, how much of the feedstock will be post-consumer or pre-consumer or B2B material, and what are the outputs going to. I hope in the future, or I'm sure in the future, ATSPs will be much more standardized as the industry moves to standardization. But now they're very much, case specific, and I think need to be designed flexibly.
Thank you both. And to sum up, I would like to ask you, what would you like for the audience today to be the key takeaway?
I would say keep an open mind to what's needed. Embrace the change that we have to be a part of, and understand that investment is going to be needed in all kinds of ways, but the return on investment is going to be worth it. It's going to pay off. I don't see any losers in this game, to be honest, and the quicker we can move towards this, the quicker we're going to have the success and see the real results. And I'm a lot more optimistic. And Joe, in 6 years' time, I want to look back and say, why the hell didn't we do this earlier?
And I would say, I think these cross-industry collaborations with willing and a broad range of ecosystem players are absolutely essential in this early stage, but we will need legislation and enforced policies to make sure that it's equally applicable to everybody in the value chain. So regulation will be needed to sustain the long-term shift. But of course, these collaborations are crucial now.
Thank you both. Thank you.